We might get started. So, hi all, I'm Blake. I'm National Vice President for SONA and on the National Climate Action Sustainability Committee. I'd like to start off with an acknowledgement. So I'd like to acknowledge the traditional custodians of the many Indigenous countries from which we are meeting from today. I'm currently on country that is looked after by the Kulin Nation and pay my respects to the elders past, present and emerging. We recognise their continued role in caring for country and hope this series of events can eventually contribute to caring for our environment as well. Sustainability Snacks is a series of short online sessions that aim to demystify sustainability in practice. And in just 30 minutes, we will hear from a practitioner on how they're reducing their impact. This is a joint initiative of SONA and EmAGN, and we hope this knowledge sharing will help to accelerate necessary climate action. So today we have Andy Bancroft from BayleyWard joining us to share their ANMF project, which is a commercial passive house project that won an architecture award at the Victorian AIA Awards in the sustainability category. And the project has also been shortlisted for the National Awards for Sustainability. BayleyWard is a design-focused practice with a commitment to the exploration of innovative social and environmental design at all levels in architecture and interiors. Before we get into it, we'll just some housekeeping. We'll have Andy's presentation, and then at the very end, we'll have a Q&A. So think of some questions and drop them in the chat. And if you could remember to mute yourself throughout the presentation, that'd be great. Thank you. Okay, over to Andy.
Good afternoon, everyone. My name is Andy Bancroft. I am presenting a project we call the ANMF House, which we are completed with BayleyWard over the course of 4 years. I'd also like to acknowledge the traditional custodians of the land where I'm speaking from today. That's the Bunurong people of the Kulin Nation. And I extend this respect to any Aboriginal and Torres Strait Islander people who are online with us today. So ANMF House, it's a very small inner urban site on Victoria Street. There are 29 hotel rooms over 6 floors, which are exclusively for the Nurses Union or the ANMF. There are 8 micro hotel rooms on level 1 behind the heritage facade, and there's a gastro pub and a basement whiskey bar below. So we set out to do a fully integrated approach to sustainable design, and we are sort of located in this heritage context. It was grade 3 listed building that contributed to the street, and it has less than optimal orientation. So I mentioned the Nurses ANMF. It's the Victorian branch. They've got over 100,000 members. They were a fantastic client in that they're an owner-operator, taking a long-term view on sustainability. So for things that maybe had a higher upfront capital cost, meant we could look at the payback period over a much longer time. Through the concept phase, this idea of caring for the carers was very strong. And as part of that, there was sort of ideas around biophilic design, nurturing, in addition to their mandate to us, which was a very high levels of sustainability. A project like this takes a very big team, so it's a big team of consultants, so I won't go through them all. The head contractor was Multiplex, so they built it under a D&C contract. And as I mentioned, we set out to do a very comprehensive range of sustainability strategies. I won't talk about all of them today. They're listed there. But the intention today is to talk about the Passive House Standard and CLT structure, where we have sort of significant savings in embodied carbon. So the site located opposite the Queen Victoria Market. I can point. Yeah, there we go. So Queen Victoria Market is down here in the bottom left. Terminates Queen Street. It's on Victoria Street, near the corner of Elizabeth Street at the end of O'Connell. The ANMF headquarters is across the road, and they were elements of the project where we shared power supply. We piggybacked off their substation. We share waste streams. They have a biodigester in their basement, so they take all the compost from the hotel and the pub. And there's also a joint management strategy. So the hotel itself, I mentioned the Passivhaus standard. We targeted the Passivhaus standard because it's really this very comprehensive fabric first design philosophy. So it's all about quality and creating a very efficient thermal envelope. That thermal envelope has much higher levels of thermal insulation than required by the NCC, for example. And then ensuring that that envelope is airtight. So once it's airtight, you can control the internal environment. And that's done with a heat recovery ventilation system. So it's mechanically ventilated, but provides 100% fresh air. And that the 100% fresh air coming in, the air that's extracted, it passes through the heat recovery system. So it's about 75% efficiency on the air. In addition to that, we need to consider thermal bridge-free construction, and we'll touch on that a little bit later, and high-performance windows. I mentioned that we had less than optimal orientation. With the Queanbeck market to the south, all our views are to the south. So our window is looking south at triple glaze. So I mentioned the building envelope. The top section on the left here is a section through typical external wall. So we use the CLT panel, which is cross-laminated timber, like a giant plywood. And then on the outside of that, we've got 140 mil of glass wool insulation. And then beyond that is the sawtooth facade that gives it its appearance. So we targeted about our 4.5 generally. And then because this is a primarily timber facade, it can't be combustible under the NCC. So it's basically wrapped in fire check, which is a non-combustible plaster. Bottom left image, I mentioned the air tightness. Basically, all the joints are taped to ensure that there's no air loss at around the edges, and similarly the windows. Now on this project, because we had almost like a stage construction, we were busy retaining the heritage facade and doing the basement excavation and the lower floors there in concrete. It gave us time to manufacture the facades offsite. So this is a picture from the factory where they're being fabricated in Dandenong, and it shows you the layering going on. So there's the CLT, the taping. Then on the outside of that, you've got the insulation, and then the membrane layer, which is a breathable membrane. I mentioned air tightness. Passivhaus standard requires air tightness to be tested. So this is fans by a company called Efficiency Matrix, and they pressurize the building positively and negatively, so they suck the air out as well as blow the air in, and it's tested to a pressure of 50 pascals. And the Passivhaus standard says of any more than 0.6 air changes per hour or at 50 pascals. So I think we took 3 goes to get there. First go we got to one air change per hour, and everyone was celebrating. Took a lot more to get down to the last bit, and they do that they have a sort of smoke that they work out where the leaks are coming from, and then they have to go and track them back and fix them. So I mentioned cross-laminated timber, or CLT. This is a typical floor plan here. You can see we've got 5 small apartments per floor. And what I wanted to sort of talk about here is this is a hybrid structural solution. So the area in blue that I've highlighted is a precast concrete core. And we needed that structurally for the stiffness because it's a very small footprint, had a tendency to twist. So the precast concrete gives it stiffness. And then around that, we have basically a timber structure. This is a picture of some of that timber structure being trained in. So it comes in very large panels. And I mentioned it's like plywood. This is a 5 lamella piece, so it's got 5 layers. What you're seeing on the bottom is the damp-proof course. So this is going onto the concrete. So they damp-proof that one. And then after that, there's a series of acoustic separators that go in between the timber. So the benefits of using timber as a structure within a traditional building, concrete or steel primary structure, there's a lot of embodied energy and consequently a lot of embodied carbon in those. So using timber as a primary structural member dramatically reduces your embodied carbon. If you do any more research on that, you'll see that it's the biggest hit on a project to reduce your embodied carbon is to target a primary structure. So these on the left, we've got some diagrams of the CLT. So during the design phase, each panel is modeled, each panel is engineered ahead of it coming in. And on the right, you can see some panels being lifted in. And at the bottom, one of the first rooms being completed before it's then sheeted in plaster. I also mentioned this off-site construction. This is because of the timing that we had, we could clad all the panels in a factory. We call them mega panels. The largest is 12 meters, which is limited by the length of the truck. And they come to site and are craned in. But what that does is it gives us exceptional quality control on the panels in terms of the air tightness and the insulation levels. And it also saves a whole lot of time, mess, noise. There's a huge number of benefits for constructing this way. Now it is part of a sequence because we are putting in load-bearing walls, load-bearing floors, and facade all at the same time. And the other thing that Multiplex brought to the table was this intelligence about they had to drop the plasterboard for each room on the floor of each room as they put the walls around it because the lift and the stair weren't big enough to move all the plasterboard up and down. So as I just mentioned, yeah, we've got these benefits for reducing construction waste, improving safety, many benefits. Now, in the introduction to Passivhaus, I mentioned the need to prevent thermal bridging. So thermal bridging is conductivity through that envelope. Now, when you do balconies, for example, that's where some of the challenges start because you need a structural connection through the facade to hold up the balcony. That's one of your major challenges with thermal bridging. So in this project, we use these little connectors you can see here on the right. They're called, well, they're by a company called Shock. And effectively, they're just a stainless steel connection rather than an ordinary steel connection. Stainless steel has a much lower conductivity than regular steel. So they put in these stainless steel connections and that creates the thermal break. On this project, when you look at the facade, you'll see as you come down from the balconies on the typical level, at level 2, we've got fewer apartments and they're larger to accommodate fully accessible rooms. So we've got 2 fully accessible rooms for wheelchairs. Now this corner element pops out a little bit. That meant that the structure coming down from the balconies then has to be transferred out. That was far more complicated than we had understood at the start, but possible. This is some on-site photos of those little connections. So those little units that you can see there, this is them between the steel column and the balcony above. So this is in the bay window. I'll show you a picture of it in a second. And this is the thermal break within the structural steel. You can see the 2 of them, one there and one there. This is a detail of that one over there. And then this is the finished product, the corner. So I think for all the extra work that it took to thermally isolate this corner, it was well worth it. Now I mentioned at the start this idea of nurturing and biophilia. One of the things we worked hard to do with the CLT structure was expose some of that in each room, so you get this timber effect in each room. Now we've got a range. We had a range of 3 colours, and they went through alternating floors. So there was always a point of difference each time you stayed. But yeah, this idea that it's comforting and nurturing. Now, in terms of choice of fittings, fixtures, materials, driven a lot by the ANMF themselves. We were very sort of, I guess, careful to choose locally produced, locally manufactured, or either that or carbon neutral if they were going to be imported. So they, for example, we used a vinyl flooring that you can see here. It comes from Northern Europe, but they have a zero carbon footprint production system. And that was really a bit of a wrap up now. So, as I mentioned, fully integrated approach to ESG strategies. There were a lot. I've only covered up a couple today. And the intention was to exemplify best practice on a small inner urban site with very poor orientation. The Passivhaus standard, it's a energy efficiency standard effectively, but it's a fabric first approach to energy efficiency to create a good quality building with a highly insulated envelope, and you'll dramatically reduce your energy consumption. We're waiting on some of our post-occupancy testing, but the target is an 85% reduction in energy consumption, 85 to 90%. So only using 10 to 15% of a typical building. With that, you get great internal conditions. So you get high levels of air quality because you're using 100% fresh air, and great acoustics, which in the inner city environment was important. And then minimum carbon footprint, so that came through the structure. And then, dramatically increased insulation levels and air tightness. And that was it. Thank you very much.
Cool. Thanks, Andy. We've got a couple of questions in the chat, but before, I've got a quick question. What do you reckon the biggest challenge was for this whole project, in your point of view?
Obviously a long project, 4 years. So a lot of challenges, none of them insurmountable. I think the biggest challenge really is trying to cram so much onto a very small site. With only 300 square meters of site, if we had followed all of the requirements of the planning scheme, of which there were competing requirements, the building wouldn't have got up. But we managed to convince Melbourne City Council that this was a good design outcome. So we didn't have to comply with the heritage setback, which, as I say, would have resulted in a footprint of about 4 square meters. We managed to convince them, and since then they've held this up as an exemplar of managing that planning process. I think that was the biggest challenge. We went through a lot of design changes with council. We've
got a question from Callum. Did you manage to get the party wall fire rating without fire check, or is the timber on the walls an additional veneer? Good question. So the CLT with fire check on both sides is basically deemed to satisfy. Under the NCC, it's quite simple. In order to expose one side to get that sort of biophilic and natural surface of steel, you move the it has to be fire engineered for start, but you move the fire check to the other side of the wall. So on one side of the wall, we've actually got twice as much fire check as the exposed side. Okay. That makes sense? Cal?
Yep, fantastic. Thanks.
No worries.
Sergio, does the sealed envelope encompass the core? How do you deal with the lift, shaft, overrun, etc.?
Another good question. So in this building, the heritage facade was considered too hard to achieve Passivhaus standards. So the Passivhaus Institute in Germany exempted those 2 floors, and we have effectively 6 floors above there and a basement that are Passivhaus standard and certified. So we therefore have 2 floors where the lift staff and its leaky doors is passing through. Now, when we did the pressure testing, those get sealed off temporarily. There are a couple of other areas that get sealed off. For example, there's a smoke release vent in the lift shaft that gets sealed. There's other elements I can't remember. Between the basement and ground floor, there's an open stair. We did get some exemptions for the doors at the top of that stair. But typically, it's just about having really good doors, door seals, windows. How it works normally.
We've got another question from Scott. What are some of the weaknesses and challenges of CLT, in your opinion?
Good question. So I think in a project like this, where we're doing a hotel with relatively small units, so the 1-bedroom unit is relatively small. It works very well. We've got load-bearing walls, relatively small spans. CLT, in my opinion, struggles a little bit once you start to do bigger spans. So once you start to do a commercial office, for example, and then you start to combine it with glulam beams and columns. You probably wouldn't do load-bearing floors, but load-bearing walls, but you would do floor slabs in CLT, and then beams and columns in glulam.
We've got a question from Jessica. Where did the CLT come from? How did you offset off the steel fixing and brackets?
Okay, 2-part question. Start with where did it come from? We use EmAGN. So these are EmAGN panels, and they came from their factory in Wodonga. The first part, and then the second part was, could you repeat it again, Blake? Something about fixing.
Yeah, how did you offset off the steel fixing and brackets?
Brackets. Are we talking about the type of fixing? Effectively, everything's screwed. Very long sort of coach bolts that get used, but coming off steel structure, they get bolted to the timber. Is that the question?
Jessica,
Yes.
carbon offset of the steel.
Carbon offset of the steel. So the steel elements in this building we've not done any carbon offsetting. All we did was try to reduce the carbon, the embodied carbon wherever we could. Some of the steel still has a carbon footprint, so does the concrete floor, the concrete base. So it's reduced, but it's not eliminated. We still have a carbon footprint.
Team 2 says, was the CLT part of the brief, or how was it justified in terms of cost?
So interesting journey. Originally, we were intending, the pub itself in its original state had a concrete structure inside. What we didn't know originally was the concrete structure wasn't very good. So we were proposing CLT with a view that we could build on top of the existing structure without destroying it. As the journey went on, the reality was we had to take down the existing concrete structure that was behind the facade and put in new concrete. So that was the journey. Once we had intended to use it because it was lightweight and required, would have let us save more of the pub structure. And then once it was in, it made a lot of sense.
Cool. We've got a question from Christina. How much change between concept to construction is the first part, or did you get to keep all the design in? If so, how were you able to keep it all? So yeah, how much change between concept to construction?
Lots. That's the short answer. The reason I say lots is we started this project without targeting the Passivhaus standard, so that wasn't the original brief. And we had a south-facing glass curtain wall, which wasn't particularly efficient. We tried to make it efficient. We tried to get it Passivhaus standard, and it was basically impossible. So the biggest design change is in the thickness of the wall. If I pan back here to one of these images, you can see the thickness and density of these walls. So that's the layers of insulation and the TLC. Previously, it was thinner. That's the biggest change.
I've got a question from Karen. I am based in Tasmania. How common is Passivhaus in Australia in commercial buildings? What factors would prevent it becoming a typical construction? That's a two-part question. So how common is Passivhaus in Australia in commercial buildings?
Yep. So not particularly common at this stage, although it's gaining traction. As I speak now, I believe this is the third largest certified Passivhaus project in Australia, but there's another one due to arrive before the end of the year. Monash University, for example, has a number of projects that have either targeted it or been built with Passivhaus standards. There are more and more coming online. Skate actively sort of started doing Passivhaus on some of their build-to-rent projects. So yeah, it's growing. What was the second part, sir?
What factors would prevent it becoming a typical construction?
Good question. I think, well, for those of us that live in the southern part of Australia, where our colder temperatures are more extreme, I guess, I think it will become much more common because of the dramatic energy savings. In more benign climates like New South Wales, there's still quite a big uptake or a big growth in Passivhaus, but I think I don't know, there's a perception that it's less important. What people maybe don't realize, and I think the biggest area of growth will come when people realize that in very hot climates, it also works particularly well. So it's a design standard that can work basically at any climate zone of the planet. And yeah, it doesn't have to be sealed up completely. It can open up. I think the biggest challenge to it becoming commercial really is the quality of the glazing. It does require very good windows, which are not equivalent to our current benchmark.
We've got two more questions before we finish up. We've got, what is the price difference between typical and sustainable method of construction in percentage?
Question. We have run the numbers on this project. There are incremental increases, but we feel fairly comfortable saying that the Passivhaus element for getting to Passivhaus standard was between 5 and 10% cost premium, which once you looked at the cost benefit analysis over a 50-year period with the ANMF, it paid itself off long before that.
And then the last question, anything you would do differently with the air tightness testing for better outcome?
I think do differently. I think detailing the way we detailed the balconies, the hardest bit on a number of levels for the balconies. So on this corner that we're looking at in this image, there is an increased surface area because you've got an inverted right angle behind there, and then there's this complexity of thermally breaking all the structure, and then beyond that, it's just the complexity of the form, I guess. So our biggest air sealing challenges were these windows.
Okay, cool. I think that's it for questions. Thank you so much for coming in and presenting to us. It was really insightful. Yeah. For everyone else, before we head off, we've locked in November's edition of Sustainability Snacks with Scott Christensen from Green Design Architects who are in Tassie. So yeah, keep an eye out, register, and we'll see you in a month. Cool. See you later. Have a good rest of your day.